Alright, we're looking at the square root of 36. We know that the square root of 36 is 6. The principal square root, the radical of 36 is 6. And then, isn't this also radical of 36? Remember, anytime we have the two factors that are the same radical being multiplied together, the end result is we're going to get a 6, because that's equivalent to this. So now we get to fractions, and we're saying, oh, we want the radical of x squared. Well, we realize that what this guy is it's really radical x times radical x. Again, we have the pair of the same radical, it has the same radicand, so the result of this must be x. After all, when you square x, you get x squared, so the positive square root of x squared must be x. So again, anytime you have the same radical, what happens when you multiply them together is you're just left with the radicand, the number under the radical sign. So if we start doing these, we realize, oh, if we factor this out, this could be written as y squared times the radical of y squared times radical of y squared. Hey, got the same radicand under there, so the result must be y squared. After all, if you square this, you get y to the fourth. So the square root of y to the fourth is y squared. You go over here, and you can break this down. You can say, hey, I can picture this as radical 16 times radical x squared times radical y to the fourth, and deal with each part separately. Radical of 16 is 4. Radical of x squared is x. Radical of y to the fourth, we said a moment ago, was y squared. So that's our final result. After all, if you multiply this guy by itself, if you square it, you're going to get right back to that. So that's why it's the square root of that thing right there. And now if we get this, again, we could break these down a little bit, but now here's the thing, that's an odd factor. So what we want to think about is we could, again, it might make this simpler to just break these down. I'm going to do this though. Look at this. If this makes sense, I'm going to write this out so I can visualize it. I know the radical of 25 is 5, that's no problem. But this guy, remember, if we can get two of the same radical, then the square root of x squared is x. We're going to bring the x out, but that x is stranded. It doesn't have another radical x to multiply by, so that we'll end up with just x. Same thing here. What this would really look like is we have a y squared times a radical y squared times a radical y. Those are identical. When you multiply those together, you get a y squared, but there's a y left. So if we combine all this together, we're going to get 5. X is on the outside, there's a y squared on the outside, and there is an x and a y underneath. This would be the square root of that bugger right there. And we could know that because if we multiplied this by itself, if we squared this thing and multiplied back the 5xy squared times the radical of xy, if we multiply this by this, we get 5 times 5, which is 25. We get an x times an x, which is an x squared, and a square root of x times the square root of x is another x, so we'd get an x cubed, and we'd also get the y to the fifth. Division works the same way. It's really no big whoop. All we have to do is say, well, the square root or the positive square root of the numerator is going to be 3y, and the positive square root of the denominator is going to be 7x squared. So that'll be our final answer there. It's time for more sophistication. Let's talk about why this is called a radical sign or a principal square root sign and not just a square root sign. This means the principal square root of 9. That just means 3. This is equivalent to 3. But wait a minute, aren't there two square roots of 9? Bet your sweet bippy there is. It's 3 or negative 3. So if we said, give me the square roots of 9, it's 3 or negative 3. But when we see this isn't a square root sign. This is a principal square root sign, or a positive square root sign, or a radical sign. The radical of 9 is 3. It's the positive of the two square roots. So that's why this is not a square root sign. So if we take that to the next level, then this also presents a bit of an issue for us too. May not make a big deal of it right now, but as time goes on and we start solving quadratic equations, this is going to become a huge deal. So here it is. We want to find the principal square root of x squared. Well, if what we just got doing was saying, well, of course it would be x because x times x is x squared. But hold the phone. What if x was a negative 3? Let's look at this more carefully. What this would be is the radical of negative 3 squared. Okay, now negative 3 squared is negative 3 times negative 3, so that would give us the radical of 9. That means the principal square root of 9. The principal square root of 9 is positive 3. Okay, isn't that what we got right here? And the answer is, no, it's not. We said this was x, but remember, x is worth negative 3. So by stating that the principal square root of x squared is x, we're saying that this principal square root is negative 3, but it's not. The principal square root is 3. So what we're going to start to get in the habit of doing is saying, hey, look, just like there's 2 square roots of 9, there's a 3 and a negative 3. And when we see the principal square root of 9, we need to report the positive of the 2 square roots. So when we take the square root of x squared, hey, this number may be negative, it may be positive, we don't know. But to make sure we're reporting the positive square root, we're going to get in the habit of saying, hey, the principal square root of x squared is the absolute value of x, so that in this situation where x is really a negative number, we're going to report as the principal square root the absolute value of negative 3, which means we're doing the right thing. We're reporting 3 as the principal square root, and that would be the correct result. That's probably pretty confusing just seeing it the first time through. You might rewind this video a little bit, but as we go forward, we're going to insist that when we start looking at that, we write it as the absolute value of x, and this, you guys, is the reason that that is not really a square root sign after all. It's a radical sign. It's the principal square root, or the positive square root sign.